Let's start off. In the last class, we had experiments, Coon's tube and the resonance column tube. Just to go back, primarily there are only two formulas. One was an open, where it is NV by 2L. Then we had open closed, which was 2N plus 1 V by 4L, or odd numbers of V by 4L. And the end correction, whenever there is an open end, there is an end correction of 0.3 D diameter or 0.68. Those are the main formulas there. So let's see a few questions on this. Whenever they say open pipe, it means open. When they say closed pipe, it actually means open closed. If it is closed on both the sides, they'll mention it. They didn't mention anything, so let's take it as a fundamental frequency. Let's get this. Second, let me help you with one. See, an open pipe resonates with a fundamental frequency F1. Like you keep saying, if you know your formulas, you will be able to handle most of it. Just draw a small picture for convenience. So let the length be L1. Frequency will be V by 2L1. V by 4L2. Now, when you combine an open pipe and a closed pipe, you will get an open closed pipe, L1 plus L2. So this will be V by 4 times L1 plus L2. Substitute here. First option. Check. So when you combine an open and open close, you get an open close pipe. What about 36? Keep going. Any notes on 35? Please ask. This thing, remember in resonance column tube, we made a statement. The difference between two lengths in the resonance is always lambda by 2. Remember that? So the difference in length between two air columns, you have to draw a picture. So the first one is this. So this is L1 plus E. This is L2 plus E. This is L3 plus E. There you can clearly see the difference. The difference in length between two resonances is always lambda by 2. L2 minus L1 is L3 minus L2. First option. Easy? Let's get them. These all are mains level questions. Let's see. A tube of certain diameter of length 48 centimeters open at both ends. That means there'll be two end corrections. So this is E. This is 48 centimeters, and this is E. So 48 plus 2E must be lambda by 2. Lambda is nothing but C by F. In this case, it is 1 meter. So basically, end correction is 1 centimeter. End correction is nothing but 0.3 times the diameter. So diameter will be 3.33 centimeters plus. Clear. Actually, this is how they find the radius of very thin pipes. If you can't use a mechanical system to measure when they break, so this is one way you can find the radius of thin pipes. Clear what we did? Keep going. Next one, 38, 39. Nothing there. This is the level of questions normally. Like you know your formulas, you substitute, you'll get the answers. That is because you didn't revise the notes. And the correction is 0.3 times the diameter or 0.6 times the radius. Don't forget that end correction. Let's see. A closed organ pipe of length L. Again, when they say closed, means one side is open, one side is closed. He said third overtone is the third frequency after the fundamental. Remember, in this, even harmonics are missing. It's a seventh harmonic or 7 half loops. And they're talking about displacement. So this is a displacement node or a pressure antinode. This is how it looks. So 7 lambda by 4 is equal to L. So K will be 2 pi by lambda. That would be 7 pi by 12. And we know amplitude is 2 by sine kx, but he gave you the maximum amplitude is A, which is A sine kx. And x is L by 14. A by root 2. Making sense what you're doing? So you need to get the lambda, then use your equation. So next one, keep going. That's it. This thing, you should know your formulas. And if you have done around 15, 20 problems, you'll get the hang of all these things. 39B 1.5. Let's see 39. So he's saying the frequency of a stretched uniform wire of certain length is in resonance with the fundamental frequency of a closed tube. If length of the wire is decreased by 0.5, it is in resonance with the first overtone of the closed pipe. Now, for a closed pipe, the resonance frequencies will be F, 3F, 5F, and so on. So here the formula will be F is equal to NV by 2L. Now you're saying when you change the length, the frequency became 3F. That is NV by 2 into L minus 0.5. Isn't it? You did nothing, you changed nothing, but the frequency became 3F. So if you just divide them, you'll end up with 1 by 3 is equal to L minus 0.5 by L. This will be 3L minus 1.5 and L will be 0.75 or 75 centimeters. Clear with this? So basically, when you change the length of the sonometer, the frequency became 3F. That's the whole story. So if you don't like that V, you can write it as T by mu. It doesn't matter when you take a ratio, it goes off anyway. Okay. Let's get this. Let's see. When an open pipe is in resonance in the second harmonic with frequency F1, so F1 is 2V by 2L, which is V by L. Then you said you closed one end of it, and the frequency has become F2. Now this F2 can be V by 4L, 3V by 4L, 5V by 4L, and so on, isn't it? Even harmonic, odd harmonics. So now if you look at the things here, so he's asking the relation. So F2 will be V by 4L. So that can be F1 by 4. So I can write it like this. So F2 will be NV by 4L, where N ka numbers are 1, 3, 5, and so on. So F2 will be NV by and F1 by 4. So if we take N is equal to 1, we get F2 is F1 by 4. When we take N is equal to 3, F2 is 3 F1 by 4. And take N is equal to 5. F2 is 3, 5 F1 by 4. So if you see, A and C are right, but he said frequency is increased to F2. So F2 is greater than F1. That's the reason first option is wrong. Clear with that? So technically, even this is right now. When N is equal to 3, F2 is 3 F1 by 4. But F2 must be greater than F1. That's why the first option, even though it is right, it doesn't work because the frequency is increased. Clear what we did? 41. Keep going. Closed organ pipe of length L and open organ pipe containing gases of density. So here, if you're messing up the density, remember the speed root over bulk modulus by rho. So speed is changing. And in any case, people forgot what is compressibility. Compressibility is 1 by bulk modulus. So indirectly it's telling you the bulk modulus of the gas is same. Others do keep your cams on. Both the pipes are all vibrating in their first overtone. Maybe, huh? Our is getting B ray. Let's see. Closed organ pipe of length L. First overtone is your third harmonic. So frequency will be 3 V1 by 4L. Second thing is open pipe. Let's call it L dash. This will be 2V2 by 2L dash. Frequency is same. This will be root over bulk modulus by rho 1. This is 1 by L dash root over bulk modulus by rho 2. So L dash will be 4L by 3 rho 1 by rho 2 to the power of half. First option, no? There again, if you see nothing, this is what I'm saying. We just take the formulas and we just keep playing with them. All these organ prep questions are like this only. All clear with this? Any doubts on this? Let's say they have a paragraph like this. Let's get this paragraph. So in an organ pipe, maybe closed or open. So he didn't tell you whether both the sides are open or closed. This weird symbol which is there is your displacement. Because you're already using y coordinate for this thing, na? So instead of using y, he's using some weird symbol. Nere purega. Let's see. Now, if you look at this, the amplitude, this is your amplitude, isn't it? This weird symbol. Two pi by 80 by plus 1 centimeter. Now notice something. If I put y is equal to 0, I get nothing. If I put y 0, I'm neither getting maximum, I'm neither getting 0, isn't it? So it's not a node, it is not an antinode at y is equal to 0. But if you notice, when you put y is equal to minus 1 centimeter, we get amplitude is maximum. Again, remember, this is your displacement amplitude. That means this is an open end, isn't it? And that is an end correction. The 1 centimeter is your end correction. So when you took that organ pipe, this point you took y is equal to 0. So somewhere here at y is equal to minus 1, you're getting an antinode. So that's a displacement antinode. So that is an open end. Similarly, when you put y is equal to 99 centimeters, that will become cos 2 pi by 80 into 100. That becomes 0. That's cos 90 or something. That means this is a displacement node. What's a displacement node? A fixed end or a closed end? So this is an open closed pipe. Make sense? So that is a clue there. If you put y is 0 and you're getting nothing, but when you put y is equal to minus 1, you're getting maximum. So that displacement antinode is forming slightly outside. So that's actually an end correction. So it's an open closed. And indirectly you got end correction is 1 centimeter, which is 0.6 times the radius. So we found the radius 5 by 3 centimeters. Okay. What about the rest? If you convert everything into meters, why will you convert everything into meters? This is given in centimeters though. See the units, no? Whatever is given, we have to stick to that. What about the second part? Think, I'll give you a minute for the remaining two. This is the formula that we have to use, everyone. You guys remember this formula? dP is equal to minus bulk modulus dou y by dou x. This is the relation between displacement and pressure. So here, when you apply this formula, dP is equal to minus bulk modulus. Instead of y, we have that weird symbol. And in place of x, we have that y coordinate. So it's a partial differentiation. So check out from here. So if I differentiate this function, partial differentiation with y, cos function should become sine. So this is sine, this is sine. Agreed? And the time the quantity should not change. So this is not changing, this thing is changing. So A is the answer ना. कुछ करने का जरूरत भी नहीं था. Is that making sense? But the thing is, you should know this formula. If you forgot this, then you're gone. Clear with this? And you can check the numerator. This should be BAK, na? Delta P max is BAK. So that is how you can figure it out. And what about this thing? 22.4 liters contains 1 mole. This is the reason why you need the end correction. The volume of this cylinder will be pi r square L. So if 22.4, 1 liter is 10 power minus 3 meter cube, gives you 1 mole, then pi r square L will give you how many moles? That's your third question. Clear with that? You know the length of the pipe and you'll get the radius of the pipe from the end correction. This is how they can play around. D. Any doubts on this? What we did? It's a good one. So if they ask a paragraph, they can play around like this. Any doubts? Any confusion? Please ask me. There, that's a bit about your organ pipes. So those are all the kind of things they can ask you. You can have more varieties, but there'll be always something of this sort. The next concept is beats. Go ahead. Any doubts so far? Anything that you're not clear, not convinced? Please ask. Clear, na, Aditya? Devansh? Pratik? Vihan? Pushkal? Ishana? Ansh? Perfect. Next thing, beats. Now listen to the derivation. Derivation is important for advanced perspective. Mains may it's not important. So what are these beats? When you take two waves, of slightly different frequency, are superposed, we observe an increase and decrease in intensity of sound. This phenomena is called beats. So what is this exactly? So let's take two equations. Phi1 A sine kx minus omega 1t kx minus omega 2t. So when you say small frequency, this is what you mean. The delta f, which is f2 minus f1, delta f must be much, much smaller than f1 and f2. Example, let's say F1 is 300 Hertz. F2 is 301 Hertz. So delta F will be like 1 Hertz, which is much lesser than F1 and F2. Now, since omega 1 and omega 2 are almost equal, we also assume K1 is equal to K2. Understand one thing, wave speed will remain same, na? If two waves are traveling in a medium, what remains same? Wave speed. So omega by K must be same. So technically K also must change. But again, since it is small, we can approximate it. We can assume K1 is approximately equal to K2. Now, when you try to solve this problem, when you add them, the resultant YR, you get 2A sine Kx minus omega 1 plus omega 2 by 2 into T cos omega 1 minus omega 2 by 2 into T. This can be written as 2A cos delta omega by 2T sine Kx minus omega average T. So if you didn't take K1 is equal to K2, you would have got K average also there. So look at this function here. 2A cos so this thing actually looks like a progressive wave, but this thing has two components. We have a progressive wave component and we have an amplitude which is changing with time. In stationary waves, we had an amplitude which is changing with position. This was a progressive wave. So what you have is a progressive wave whose amplitude is changing with time. In case of a stationary wave, the amplitude of a particle was constant. So how does this look like? So let me try to put a waveform for this. I think that will be a better thing. So if I just try to draw a regular equation, y is equal to a sine kx minus omega t. And let's say you're plotting yt graph. Matlab for a given x coordinate, you're plotting how y is changing with t. So if you put x constant, it is a sine function. It's a high frequency, so the waves will be much closer. Something of this sort. So when you try to hear this sound, you know what you'll hear? See, we humans have a problem. If the frequency is greater than 10 hertz, you think it's a continuous sound. For example, let's say if I'm saying like tuck, 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 see, you know, there are different sounds. But if I do really fast, like tuck, 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 right? If I let's say 20 times per second, you will think it's like a constant sound. Try to do this and see. If you have a fan now, put it on the slowest speed. Tuck, 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 tuck. It does that sound, isn't it? You put the fan on full speed. It still does the sound, but you can't hear that. You will think it's like a continuous sound. Ever happened to you? When you put the fan on slow speed, you're feeling cold, you decrease the fan speed, starts making noise, you get irritated. Then you just increase the fan speed and put a blanket on yourself. So when the frequency exceeds 10 hertz, right, we humans cannot distinguish. Happens with you this thing also. If if two of your friends are trying to talk to you at the same time, what happens? You don't understand any of them. Because both the sounds are coming within a gap of 0.1, both the things get mixed up. Your brain can't figure out what they're talking, and you'll say, "Yeah, boss, shut up, yeah. One of you speak." Why everyone is talking? I'm pretty sure your teacher must have done the same. Teacher asks you a question in the class, and everyone is shouting. No one understands what anyone is talking. So the reason is this: so any frequency greater than 10 hertz, we cannot distinguish. Yeah, for some people it is 10, for some people it is 12. Varies a bit, but yeah, will be heard as a constant sound. That means if you take a progressive wave and if you sound it, this is what you'll hear. You'll just hear a constant sound. Basically, you'll be hearing these peak values. You're getting it? You'll just hear the peak values. You can't, your ear cannot differentiate that decrease, increase there. You will think it is a constant sound. But if I try to draw this guy, you will see something. So when you draw y is equal to 2a, delta omega by t. Look at this graph. So it's still a progressive wave, but your amplitude is changing with time. So when you put t0, you get maximum amplitude. As time passes, your amplitude decreases. Means you're still getting a sine waves, but the sine waves amplitudes are dropping. Eventually you become 0, then again it increases. It goes up and then again it decreases. 0 and then again it increases. You're getting? This is what you will see. So you know how will this sound here like? So if you start from here, it is like you will hear this thing. You'll increase and decrease. Because see, there's a time interval, isn't it? But there's a huge time gap. You will be able to distinguish this. So this sound you will hear increase and a decrease. Increase and a decrease. So basically this is called one beat. So when all had same amplitude, your ears cannot distinguish it. You will think it is like continuous on, but this thing will be like, this is how you'll hear it. So basically these shapes are called waveforms. This is a YT graph of a progressive wave, for beats. In your phone, you can actually download an app called Tone Generator. I could not install it on my tab for some reason. So for now, we have to adjust with this. Let me show you how beats will sound like. So there, this thing I showed you before, but so you can see that box kind of thing. That's kind of like an organ pipe. So open end, and you have a this thing, a tuning fork. So when I take a tuning fork and hit it, can you hear that sound? Continuous sound. That is how a sound will be like actually, a progressive wave. Now see what he's doing. He's taking two tuning forks. Both are identical, but on the left one he kept a weight. And this thing we studied before, if you remember. If you add weight to a tuning fork, what happens? It becomes more difficult to vibrate. So frequency decreases. So indirectly, you have created two tuning forks of different frequency, isn't it? Now, when you sound both of them together, there is a difference in frequency. We should hear beats. There is just continuous sound. So you can actually install the app called Tone Generator. In that app, now you can generate 2 to 3 frequencies at the same time. So you can put one as 500 and one is 502 or something. You will hear actually 2 bits. Phone maybe can do that. I tried downloading that app. I don't know why. Phone mein to it is there. Google Play mein it's not showing anymore. Okay. But clear with that? So that is how beats will be sounded like. So what you're hearing is actually not the wave. What you're hearing is this envelope, isn't it? When you join all the peak values, you're hearing the envelope basically. So how many beats will you get every second then? So let's try to calculate that. So we know the amplitude is 2a cos delta omega by 2 into t. We know frequency is omega by 2 pi. So here the beat frequency f will be delta omega by 2 pi, which is 1 by 2 omega by 2 pi minus omega 1 by 2 pi. This is nothing but f2 minus f1 by 2. Even you can see in this picture also. Can you see this? In one full cycle, you get 2 beats. Right? In one full cycle, you get 2 beats basically. In one time period, we get 2 beats. Therefore, number of beats will be 2f. So the formula is pretty easy. That's what I said. For a mains level, you need not know all this derivation. 2f, which is simply mod f2 minus f1, depending on which one is bigger. At a mains level, this formula will do. The derivation is important. I'll show you how to frame a question in advance. And like I said, again, if the number of bits exceed 10, we cannot hear it, but beats are there. Machines can still detect them. And actually, this is the process, we will see later on in Doppler effect. Using this, you can actually find the speed of the vehicles. How do you know in a cricket the ball is going with the speed of 153 kilometers per hour? Who goes and actually catches the ball? So the number of beats per second is exceeds 10. Humans cannot distinguish it. It goes beyond our range. You think again it is a continuous sound. Clear with this? Well, that is the theory of beats. Let's see a question. Any doubt so far? We have two tuning forks, FA, which is 500 hertz. FB का frequency, we don't know. Initially, A and B produce 4 beats per second. But when wax is applied to B, number of beats become 6. So beats have increased. Find the frequency of B before waxing. Standard Baines level question. Matlab, this is a standard one. Comes a lot. Get this. It's an easy one. I'll give you a minute. Yeah, so if you got it. Yeah, 196. See, there are only two options here. When A is 500, and you're saying that 4 beats you're producing, so B must be either 496 hertz or B must be 504 hertz. There are two possibilities because the difference is 4. But whenever you put wax, FP decreases. So if you decrease further than 496, then the number of beats would increase. But if you try to put wax on this 504 guy, again, remember, wax does not really have too much weight. It will decrease the frequency by maybe 2 to 3 hertz. So this thing also decreases. If 504 decreases, it becomes 502 or something. So the number of beats will decrease. And in the question it is given, it is gone from 4 to 6. So this is right and this is wrong. So therefore FP is 496. That is how you eliminate one of the possibility. Clear with this? I know there is a possibility. Put so much wax that 504 becomes 494 or something. But like I said, wax really cannot change so much frequency. Clear with this? Hmm. Beats and sonometer, beats and organ pipe. So beats, the concept is straightforward. If you have two sources of different frequencies, the difference is beats. Bas ho gaya. Now, how do you get the two different sources is a game. Did you get the picture? So we have a sonometer. He's saying the fundamental frequency is F naught. So F naught is V by 2L. Then what you did, you kept a bridge in the middle. This length became L by 2 minus delta L. This length became L by 2 plus delta L. And each side is oscillating in its own fundamental frequency. So iska frequency became F1, which is V by 2 times L by 2 minus delta L. You can take out L by 2 common. It will be V by L. 1 minus 2 delta L by L. You can use binomial approximation because delta L is very small. This guy becomes 2F naught 1 plus 2 delta L by L. Similarly, F2 will be V by 2 L by 2 plus delta L. This will be 2F naught into 1 minus 2 delta L by L. There, because you kept the little distance, the frequency got messed up. So the number of beats will be f1 minus f2. That would be 2f0 4 delta L by L. 8f0 delta L by L. First option. Making sense what we did? This is what I said. You should know your formulas and you should have seen some models. You'll get the hang of it. They're not tough. You just have to keep playing with the formulas. Try 45. It is based on sonometers now. And we had to use binomial approximation because delta L is much smaller. Here you're messing with the temperature. So speed of sound changes. See. So we have an organ pipe air column. Now, thing is, it didn't tell me whether it is an open, closed. It doesn't matter actually here. So when you take this, you can take anything you want. F is equal to NV by 4L. This is proportional to V and this is proportional to root T. We are interested in the temperature. And what is initial temperature? 627 degrees. Make sure to write it in Kelvin. This is 900 Kelvin. Then you had a tuning fork, which was generating, let's say, F0, and let's say this is F1. So F1 minus F0 was 6 Hertz. Then when you decrease the temperature to minus 48, which is 225 Kelvin, the frequency became F2. And he's saying F2 minus F0 is 0. There are no bits, so F2 became equal to F0. So F1 by F2 will be root over T1 by T2, which is root over 900 by 225. 2 is to 1. So F1 is to F2. Take this and substitute here. We get 2f2 minus f0 is equal to 6, but f2 is nothing but this. F0 is 6 hertz. Make sense? So the tuning fork frequency was 6. Initially, it was having 12 hertz, and then when you decrease the temperature to 48 minus, it became 6 hertz. That's why there are no bits. It doesn't matter whether it is an open or open closed because it's proportional to V. Root T doesn't matter. Clear with this? I think it would matter, I guess. It would matter. It should be open, open only. You know why? Look at this ratio 2 is to 1. Na? If it is open closed, the numbers will be odd numbers, isn't it? 1, 3, 5, 7. You won't get 2 is to 1 ratio, isn't it? If f 3f 5f will come, that ratio will never be 2 is to 1. So this should have been actually open open, but yeah, luckily the answer will work out. I will just write this thing as f proportional to b. Clear this? There, that way. Take a break. Come back by 9:45. We'll continue from here. Any doubts so far? Chalo, come back in 5 minutes. This was the old mains question. They simply asked the number of beats per second. That's an easy one. But if I ask you find the ratio of intensity of beats, suddenly this becomes an advanced one. Let's get this. Now you have to go back to the derivation. You can't use any of the formulas that I taught you, because all the formulas we derived is only when you have two sources. Think for a minute, how will you approach that? And I'll give you an idea. So let me give you an idea how the equations will look like. So start from here. Let the equations be y1 is equal to a sine kx minus 2 pi. Omega is 2 pi f, no? So f minus 1 t. So y2 is a sine kx minus 2 pi ft. F plus 1 t. We have to add all these three, isn't it? So my suggestion, when you add them, do one thing, add 1 and 3 plus first and then add y2 next. You will see something nice. Get it? Isn't that what we did for when we did the Beats thing? We took the two equations and we added them. There we took as omega 1, omega 2. Here we're taking f1, f2, f3. Phasors. Remember to use phasors, what should be same for Roja? They should have same frequency. Phase angle can be different. You cannot use phasors if omega is not same. What did you get? When you added y1 plus y3, you'll get 2a sine kx minus 2 pi ft. And then you would have got one term called cos 2 pi t. Plus a sine kx minus 2 pi ft. So if you take out that a sine kx minus 2 pi ft common, you will end up with y is equal to a into 2 cos 2 pi t plus 1 sine kx minus 2 pi ft. There, it's a progressive wave, but whose amplitude is changing like this. This is your amplitude. And you can clearly see here omega is 2 pi. That means time period is 1 second. And look at that function there. If you look at the cos function, cos 2 pi t can go from +1 to -1. That means this amplitude ka value, if you just look at the magnitude, when it is +1, it will go to 3. When it is -1, it will go to 1. So for this, if you try to draw the waveform, it would increase, it would decrease. So in half cycle, in another half cycle, it would go to 3a and then this is how it looks. So it would be like some small sound, big sound, small sound, big sound. So that is how it will be. So this amplitude is a and this amplitude is 3a. And this is happening in 1 second. Isn't it? In every 1 second time period, it is going to a and it is going to 3a. And we know intensity is proportional to amplitude square. Therefore, the ratio of intensity of the beats is 1:9. So you get one big sound and you get a second sound 9 times bigger than this. So we get 2 beats per second with intensity 1:9 ratio. Making sense? Because when cos ka value varies from -1 to +1, that entire amplitude ka value will vary from -1 to +3. If you just take the magnitudes, it's fluctuating between 1 to 3. So remember the general result for a mains level question. Mains may they ask this question only directly, like how many beats are there? They didn't ask about intensity. So if you have f minus n, f and f plus 1, so if they form an AP, then the number of beats will be simply just take the first and the last one there. Number of the beats per second is 2n. Mains or CET level question. They'll not ask about intensity. Clear with this? That's how you handle if you have 3 sources are oscillating at the same time. Because 2 sources ka beats is fine, but 3 you have to derive it again. Clear with this? Yeah, that is about beats. So beats as such, it's not mains level, it is very easy. Advanced may they can still play around a bit. Next thing is Doppler effect. So Doppler last year they removed it from the mains portion, but they kept it in the advanced portion. That is because mains people, right? They suddenly messed up in the middle of the thing. They changed the portion. So advanced people didn't do anything. This year we don't know. They might change it. So we will not know until the portion comes out. So, but still we will do it anyways. Because advanced may they will always put a paragraph and say there we explained it. And it is anyway there for bits. So karna hi padega. And I think 2 days back, bits ka cutoffs have come out. Matlab this year ka bits cutoffs have come out. I hope you have seen. In case you have not seen, cutoffs have gone down a little bit drastically. Last year, bits Pilani computer science was 327. This year, you're getting it for 304. That's a huge drop, almost 20-23 marks ka drop. Now, one thing people said paper became tough, but people didn't take also. When will the portion come out? We have no idea. I think when the portion cuts over, then the portion will come. And last year, bits Goa ka cutoff was around to 300 ka aspas tha. Is bar 296, 300 ka aspas. I think this time it went to 280. Hyderabad ka CS was 270. So yeah, compared to last year, this year ka cutoffs went down by almost 20 to 30 marks. 20-25 marks ka cutoffs have gone down. So that is there. Anyways, so that's a little about things. Anyway, next month we are going to have one session, about different colleges and all. And I think after that, every month almost we'll have a PTM. We will have it till March. Let's see. So Doppler effect. So what is this? So when there's a relative motion between the source and the observer, the observer hears a frequency different from the source. This phenomena is called Doppler effect. So what is happening exactly here? So let's take 4 cases. Case 1, observer is at rest and source is moving. So let's say we have an observer just sitting there. We have a source, maybe a tuning fork or something, having frequency f. So time period is 1 by f. Remember, frequency is nothing but number of pulses per second. So t will be the time interval between 2 pulses. Let the vehicle ka speed be vs. C is the speed of sound. So at t is equal to 0, your thing will generate your first pulse. So the second pulse will come after what time? After capital T. So during that time, your first pulse must have already traveled till here. So this thing must have traveled a distance of C into capital T. During this time, do you think the source will remain at rest? Source has moved forward. The source must have come somewhere till here. How much? Vs into T. And then it generates the second pulse. Now, what is the definition of wavelength? The distance between 2 pulses, isn't it? But what will this guy think now? This guy will think the distance between the pulses has decreased. He will think this is your new wavelength. So this person will think the waves are getting closer. So lambda apparent will be Ct minus Vs into T. So he will hear a different frequency f apparent, which is C by lambda apparent, which is C by C minus Vs, and T is nothing but 1 by f. So he will hear Cf by C minus Vs. He will hear a frequency more than what is being generated. This is because when the source is coming forward, the pulses are getting closer. He will think you're getting more pulses per second. So here observer feels, the observer thinks the wavelength has decreased. Clear with this? If you think about this, you must have seen this in some video or something when this F1 race car is happening, right? And when you're standing near the stands, right, you will hear this sound. Ever heard this kind of sound? So that is when the vehicle is approaching you, you hear high frequency. When it is going away, you hear low frequency. That is the sound thing actually. But high pitch and then it just dampens off. So let me tell you the same thing with a more simpler example, like kinematics one. Look at this thing. Let's say you're standing here at rest, and I'm standing here somewhere far. I'm also at rest. And now what I did, I started throwing stones. I'm throwing one stone every second. with a speed of 1 meter per second. Distance between you and me is 10 meters. Okay. So the first stone which I throw, when will the first stone reach you? The stone which I throw at t is equal to 0 will reach you after what time? T is equal to 10. The stone which I throw you at t is equal to 1, when will it reach you? T is equal to 11. The stone which I throw at t is equal to 2, because it takes 10 seconds to travel, right? It takes 12. Now, if I ask this person, boss, if I ask this guy A and if I ask this B, A will say I'm throwing 1 stone per second. B will say I'm receiving 1 stone per second. All are happy. Now, same scenario. Let's say this time A started walking. A started walking with a speed of half meter per second and is still throwing 1 stone per second with 1 meter per second with respect to ground. Okay, his speed won't add up. Now you tell me, T0, the first one which I threw, when will it reach the person? T is equal to 10. When I throw the second stone, right, am I still at the same place? When I throw the second stone, I must have walked a little forward. How much? Half meter. And this distance has become 9.5 meter. So I'm throwing the stone from here. So the stone which I throw at t is equal to 1 will reach the person at what time? 9.5 seconds plus 1 second initially. So it will reach at 10.5. The next stone, I will walk a little more forward. T is equal to 2 seconds. Now this thing has become 1 meter. This thing has become 9 meters. When will the stone reach? It will take 9 seconds to travel. And I throw it after 2 seconds. So it will reach at t is equal to 11 seconds. Now, did you notice something? A is throwing 1 stone per second, but B is receiving 2 stones per second. Isn't it? In the 1 second interval, I got 2 stones here. Basically, this is what is happening in Doppler effect. Just because the observer started walking, the stones have to travel less and less distance. Right. So it gives an illusion to the observer, as if the stones are more stones are being thrown every second. Is this making sense, everyone? Simplistic example with stones and stuff, but you can see this is actually a Doppler effect. So when the source starts moving, the frequency gets messed up. In this case, it is the number of stones per second. In this case, it is the number of waves per second. Clear with this? Same thing, case 2. Let's say observer is at rest. And let's say this time the source is going backward. So this is your first wave. So after some time, the first pulse will come here. This will travel a distance of ct. The source must have gone backward. This will be vst. This is your second pulse. Your lambda apparent will increase. So this person will think the wavelength has become more. So f apparent will be c by lambda apparent. You get cf by c plus b. C will hear less frequency. So there, this is an important thing. So whenever the source moves, wavelength gets affected. That's where the frequency gets affected. Clear with this? This is what happens when the source starts moving. What happens if the observer starts moving? All clear so far? Case 3. Observer is moving, source at rest. So this guy is running with VO. source is at rest. So this is generating waves continuously and the wavelength doesn't get affected. It is coming with speed c. So if you ask him, boss, what is the speed of sound, what will he say? He will think sound is traveling faster. So when the observer moves, speed of sound gets affected. Therefore, C apparent is C plus V naught. F apparent will be C apparent by lambda. This is C plus V naught and lambda is C by F. CF by C plus V naught. Yeah, C plus V naught by C into F. Again, you'll hear more frequency. But remember, the reason why frequency changes is different now. Whenever the observer moves, the speed of sound gets affected, and that's where the frequency gets messed up. So they're affecting different quantities. Same thing if he goes with V naught this way and the source is at rest. So we will get F apparent will be C minus V naught by C into F. So when observer moves, speed of sound changes. Clear with this? This is called a ripple time. So you have a glass, you have water on top of it, and there is a needle there which is continuously hitting the water. And they keep a light at the bottom. And you can see the reflection of the ceiling. And now you put that thing projected on a screen. How the picture would. You can see what is happening there. There is a needle there which is on the water surface. When it is oscillating up and down, it is generating waves. Can you see the difference between two waves? That is a wavelength. And they ka sab same tha. So you can see the pulses actually. Each pulse is being generated. So speed of sound, right? Speed of the wave is f into lambda. So if the frequency is less, you have more wavelength. If your frequency is more, you have less wavelength. Now you have less frequency. It is oscillating slower. Can you see the distance is bigger? But if you increase the frequency, you oscillate faster. Now can you see? Now more waves per second. Now what happens if you move them? So this is your Doppler basically, isn't it? Now you're moving the source. Did you notice this? Look at the waves in the front, they're getting compressed. Look at the waves at the back, they're getting expanded. That means anyone standing in front of the source will hear high frequency. Anyone standing behind will hear low frequency. And if you move this faster, you can see this even more clearly. If you're moving faster, now can you see more clearly? The waves in the front are getting literally clumped and the back they're expanding a lot. So the faster you move, the more the change in frequency. What if we move really fast, faster than the speed of the wave? We move so fast. This is how it looks. You actually create a shock wave. Basically, the waves which are being generated, they can't go faster than the source. They start accumulating in front of the source. All these waves will get compressed. So what will happen? You'll get amplitude A plus A plus A plus A plus A. They're all adding up, isn't it? The intensity will just blow off. You get a huge energy. It's like a shock wave. This is what they show in the movies, now when the fighter plane goes faster than the speed of sound, glasses break, buildings will shake, and all that stuff. So that is a shock wave. You can see the shape how it is coming. So anything within that region, right, will get affected by the shock wave. It's called a Mach cone. So that is how it would kind of look like. Clear with this? Now, if I combine all these four cases, the formula becomes like this. F apparent is C plus or minus V observer. Observer is in the numerator, C plus or minus V source in the denominator into F. So when to use plus, when to use minus. So listen carefully. This is not any thing. It is just a mathematical thing which I used to use in 11th and 12th. A simple thing. If observer moves towards the source, now see, I don't care about the actual velocity. If I'm trying to go towards you, what will happen? Frequency will increase. Similarly, if source moves towards the source, observer, frequency increases. Again, understand one thing. It doesn't matter if I don't get, let's say you're going with 20, I'm going with 10. I don't care about your speed. What am I trying to do? I'm trying to get closer to you. F increases. Okay. So let's see the observer, the source. Let's say observer is going this way, source is also going this way. So listen to the formula, how it will come. F apparent, first thing. What is the observer trying to do? Go towards the source. So frequency should increase. Where is the observer velocity? In numerator. So to increase, should I put a plus sign or a minus sign? Plus sign. So C plus V naught. What is the source trying to do? Go away from the observer. So frequency should decrease. But where is source ka velocity? Denominator. So how to decrease? By putting a plus sign. Is that making sense? So you just need to check whether it will increase or decrease and appropriately put it. For example, if it is this way, what will you do for this guy? What is the observer trying to do? Observer is trying to go towards, so frequency should increase. What is the source trying to do? Source is also trying to go towards you, so frequency should increase. But source ka velocity is in denominator, so minus sign hona chahiye. Are you getting how you're guessing the signs? That's it. So there's nothing, not a big logic or anything. So what will be the answer for this? Clear with this? Any doubts on this? All clear when to use plus, when to use minus? That's a simple way to remember. If I try to come towards you, whether I'm coming or not is a different story. I am trying to come towards you. Frequency should increase. Clear with this? Now, this formula can be even further enhanced. What happens if there's a wind blowing? The formula becomes V, C plus or minus wind, plus or minus V observer by C plus or minus wind, plus or minus V source. Do you guys remember wave speed ka formula which we derived? Root over T by mu and root over bulk modulus by rho. These are velocity with respect to what? They are not velocity with respect to the ground frame. They are the velocity with respect to the medium. So if the wind itself is blowing, your speed of sound will get affected. So W is your wind speed. So two cases. Let's say observer is standing here, source is here. The sound waves are going this way. And let's say wind is also going this way. You tell me, will the wind support the sound or not? It will support. So F apparent will be C plus W plus or minus V naught. So that V naught and Vs ka signs, you will get it from the previous one. Vs into F. Making sense? Same thing. Sound is traveling this way, but the wind is blowing in the opposite direction. Should always check. So it will be C minus W. Clear with this? So wind blows in the direction of propagation of sound. There, if you have a wind, this is what you do. Clear with this? You can put on that formula. You're going to need that. There's actually another level of formula which we'll see in the next class, but for now, let's play with this. So this formula is valid only under some cases. So this formula is derived when all the speeds are constant and all are on the same line. So this formula is valid when observer, source, and the wind are along the same line. With constant velocities. That is one. Second thing, this is important. Never use relative velocity. Because unfortunately, when I defined it, I used the word when there is a relative motion, there's a Doppler effect. So that might give you a feeling I'll use relative velocity. But look at the problem here. When the observer moved, what changed? Speed of sound changed. So numerator got affected. When the source changed, what changed? Denominator got affected. So if you use relative velocity and try to solve, you will mess up. That the formula doesn't work. So be careful. Never use relative velocity. Always solve in the ground frame. Because both the quantities are affecting different things. That is, V observer and V source are with respect to ground. That is one. Second thing, people are so obsessed about F apparent. Sometimes what they will do in more than one choice question, they'll ask you for lambda apparent. Right? Then how do you find lambda apparent separately? Luckily, it is there within the same formula. C plus or minus W V naught by C plus or minus W plus or minus Vs into F. So if you just bring that F down, you will notice this is nothing but C apparent by lambda apparent. So if they ask you for lambda apparent, you just find your F apparent and bring that F down. Clear with this? Because wavelength will get affected only because of the source. Observer will never change the wavelength. That's one important thing. Because most people, when they ask lambda apparent, they get confused like how to get that, but it is there within the same formula. Clear with this? Let's see a question which will take care of all this. Any doubts so far? Let's see a question. Yeah, if you do this question, I think all your basic problems will get over. Let's say we have a vehicle. Vehicle is going with 10 meter per second. In the middle of the vehicle, you kept a siren. Frequency 500 hertz. Again, don't worry too much about the numbers. We will just this thing. And we have six observers. We have A here, who is running with 5 meter per second towards right. We have B here, who is running towards the vehicle with 5 meter per second. We have C here, who's sitting in the front seat. We have D here, who's sitting in the back seat. So C and D are not moving. C and D are sitting in the vehicle. So that means they have the same speed as the vehicle. E is running towards the vehicle. F is running away from the. This literally covers all the cases. On top of it, wind is also blowing from left to right. The total 6 observers are there. Find F apparent and lambda apparent for A, B, C, D, F. Let me show you one question for you. Let me show you for A. Speed of sound is 330 meters per second. Okay. So listen once. Let's do for A. F apparent, the formula is C plus or minus wind plus or minus V observer by C plus or minus wind plus or minus V source into F. Okay. See, first thing, how is the sound traveling? Sound is traveling from here towards right side, isn't it? Sound is going from left to right. How is the wind blowing? Left to right. So it is supporting. So it is plus. So C plus wind. What is the observer trying to do? Observer is trying to run away. So frequency should decrease. The minus VA. Don't put the numbers, just leave VA, VB and all. Done. Denominator also C plus W. Understand, when you put plus W, denominator also will be plus W only. So that wind has increased the speed of sound. Are you getting it? C became C plus W. What is the source trying to do? Source is trying to go towards the observer. So frequency should increase. So minus V of the vehicle. I'll just write Vs into F. You're done. So what is lambda apparent? Bring that F down. C plus W minus Vs by F. What is C apparent? The numerator. C plus W minus VA. Got it? You can leave like this. Understood what I'm asking? Can you do for BCDF? Get them. C and D are interesting. There, if you get this sign conventions, you will be comfortable. You'll understand when to put sign, what sign and all. Yeah. Wind speed will apply in the car. I mean, chalo, I understand your point. Assume there are windows and everything. So just think of like this, na? C and D are running beside the vehicle with 10 meter per second. It's an open bus. Maybe I should have given like this, I guess. Happy. There's no roof on the bus. You got the point. So yeah. That is right, Puroj, but I'm more interested in lambda. So exam में क्या पूछेंगे पता है? More than one choice में observer C and D will observe same frequency and same wavelength. Option would be something of like sort. Observer C will see same frequency but increased wavelength. Observer C will see same frequency but decreased wavelength. So options would be of that sort. Most people will get that frequency part right. Wavelength they'll go for big time. Let's see for B. That you must have done by now. So FB. C, wind is supporting. This guy is coming towards you. C plus wind. This is also coming towards you minus Vs into F. And bring that F down, you'll get lambda apparent and all that stuff. So yeah. Now look at for C. Listen for C in case you didn't get this. C, what is the wind doing? See, forget about the vehicle. Just imagine like this. Imagine C is running on the road with 10 meters per second. The wind is supporting plus W. And what is C trying to do? C is trying to go away from the source. Now, this is the important thing. C is not actually going away from the source. I don't care about that. What is C trying to do? That was the question. C is trying to go away. So frequency should decrease. So that is VC. But here luckily VC is equal to V source by C plus W. What is the source trying to do? The source is trying to get closer to him. So minus Vs into F. This will come out to be F. Same frequency because Vc is equal to Vs. But what is lambda apparent? Lambda apparent will change. C plus W minus Vs by F. He will not see the same wavelength. The reason why the frequency comes same is because C apparent is messed up. Lambda apparent is messed up, but the ratio is remaining same. So most people will get this mistake. They think, yeah, there's no relative velocity, so frequency and wavelength is same. That explanation itself is only wrong. You're getting it. So if I show the same thing for D, the wind is going back, so minus W. The D is trying to come towards you, so plus VD. C minus W, this is plus Vs. This is equal to F. Observe this, lambda apparent is different for C and D. Did you notice? C is seeing C plus W minus Vs. This guy is seeing C minus W plus Vs. Both of them see different wavelengths. Obviously, na, because when the source is going front, the waves in the front will get compressed, waves in the back will get expanded. So C will see kind of more frequency than D, more wavelength than this thing. So this is important. Right? Most people, na, they think like this. Since relative velocity is zero, frequency remains same or F apparent is zero. This explanation is a blunder. In assertion region, if they give this as an explanation, this is a blunder. This is not the explanation. Relative velocity has nothing to do with your F apparent zero. Are you clear with this thing? This is completely a wrong explanation. But most people think since there's no relative velocity, so it should be zero and all. It doesn't work that way. If relative velocity was the reason, then even lambda should not have changed. Lambda changes. So be careful with that. F remains same, but lambda changes. Will it increase or decrease? That again depends on the wind speed. W is 20 and V is 10. So if I can adjust the wind speed, I can actually make it increase or decrease. I can even make lambda same also if I make W and Vs same. So lambda actually depends on the wind speed and the vehicle gust speed. Clear with this? Can you do for E and F? They're easy, they're almost done. That will be a good more than one choice question, right? For C and D. Fe will be C, wind is opposing, E is coming towards you by C minus W, vehicle is going away. The frequency should decrease. Wind is going away, you're also going away. Clear with us? There, if you got all the 6, you got all the signs. Frequency lambda will be smaller for C. Why here Aditya? It depends on the wind speed also, na? यहाँ पे lambda देखो ना कैसा आ गया. C plus W minus Vs. So in this scenario, W is 20, V is 10, so lambda increased. No? So wind speed will depend करेगा. Wind is not there, then you could have been pretty sure. Any doubts on this? There, Doppler ka, this is the main thing. In this, there is one more variation. What happens if the observer and the source are not on the same line? They're going at an angles. That is one more case we will see in the next class. So mostly next class, I think another 1 hour maybe we will wrap up this part and then we'll start off with wave optics introduction. So there's not much left in this. So you can actually start solving. Do finish it off. Whatever waves on a sound waves, whatever material you're doing, start doing. If you're doing HCV, there are 2 chapters in it separately. So start working on this. I think we have done almost, 47 questions. Yeah. We will do another 6-7 models on different stuff and then we'll wrap it up. Okay, with that, we'll wind up for the day. I'll see you guys again on Monday. And do remember, there's a test online till tomorrow night, so make sure to give it. So I'll extend it till Sunday afternoon, 12 o'clock, in case you can't give it till tomorrow night. So that's the maximum. I'll post the results on Sunday afternoon. So try to give it before Sunday afternoon, 12. So, okay. Any doubts, anything else, please stay back and ask. I'll be free to leave. I'll see you on Monday, same time. So